Okay, dear students, so we can continue the sessions up to 12 sessions. Now this class is session number 13. In this session, the topic is iteration and recursions. Right. So I think you already know the concept of iteration and recursion. Normally in the first semester itself that concept comes. Iteration is there, then recursion is also there in C language, in the C++ also. Any programming languages, all that programming languages, either early languages or the advanced reset languages, all computer languages normally contains iterations. Iterations is nothing but a loop, right? So here in this topic that contains concept of iteration, here iterator symbol is available in Python. Okay, so here is suppose I take here x is equal to 1 to 3, I directly initialized that values to the variable x. That function iterator, then that increments a next value, step value. Here that 1 2 3, after that it stops for repeating. Here in this Python, what are Python iterators? Here in this Python iterators, an iterator is an object that contains a sequence or countable values that can be traversed upon, right? So here in this we consider that iterator is an object in Python programming. If you observe in this diagram, that contains, so then in the diagram that contains a check condition. Whenever that control comes to the check conditional or conditional area, it checks the condition. After checking the condition, it checks the boolean values. If the condition is true, it exiting from loop. If the condition is false, body for loop, it executes the whatever the instructions written inside that. Okay, we come to that iteration or looping. It means repeat the same statement or a block of statements again and again until some condition satisfies. Here inside that condition you observed last element reached. Last element reached means suppose that range is 1, 10, so that time when that control reaches the value 10, so that time it comes to the exiting loop. Otherwise, which process the either a single statement or a block of statements again and again until some conditions satisfied. Normally we say that it is a loop or iterations, right? So you observe this, we are taking an example as a for loop. The for loop statement is used to iterate or repeat itself over a range of values or a sequence, right? That's either a list or a tuple or a dictionary or a string. In this Python programming, we have to apply that loops to these means either to a list, a tuple, a dictionary or a string. Okay, you observe that syntax of a for loop is iterating variable, means it is a loop control variable in sequence. If that satisfies, then statement 1, statement 2, that indentation is 4 space forward that statements. So for loop that index is at the first line. You observe statements or that indexes are nearly forward to 4 spaces. Otherwise, you can use that use of range, means that range contains initial value, final value, means step. Step means either you increment the value by 1 or increment the value by 2, so that represents a step value. So here that what is that a Python iterator, it is applicable for the tuples, numbers, list, sets, range, strings, and dictionary also. Here you observe here a iterator that versus iterable. Iterator versus iterable. Here that iterables are objects that act as iterable containers to get the iterator. That is the iterator versus iterable. Okay. So observe here iterator. So it is a function that next that moves to the value to the next value. Here creating an iterator. Creating an iterator means here so that a creator, to create an iterator, we need to implement the methods iterator and next method. Okay, by using iterator method and next method, we have to creating an iterator. Okay, by using that for loop, we can print our tables, means multiplication tables. Suppose if you put that range within that loop, observe, suppose I take here, print the table of any number, means if you want to take table is equal to 4, t is equal to 4, so that time which prints the multiplication table of 4. Suppose if you have to initialize that t is equal to 8, so that time which prints the multiplication table of 8. Okay, you observe that loop for num is a variable in range 1, 11, because up to 10 it prints. Okay, that loop repeats from 1 to 10, so that time it prints the multiplication table. So you observe that output statement x, that is x, it is represented as a into mark, as it is with that is there in double quote, as it is it which prints on the output device. T comma, T means we are assigned that we want 4th multiplication table, so that time we have to assign t is equal to 3. Suppose if you want to multiplication table of 6, so that time you have to assign t is equal to 6. So inside that print method, you observe t comma, our given value, given multiplication table value, comma, that within the double quote, whatever that it is x represented, it is a into mark, because that symbol is represented within the string constant. Whatever that symbol as it is prints on the screen, double quote comma, num is the variable, it values that first time that value is 1, after that 2, 3, 4 up to 10 it prints is equal to t into our given number into num. So you observe that output result 3 into 1 is equal to 3, 3 into 2 is equal to 6, 3 into 3 is equal to 9, like that our multiplication table prints by using a for loop that repeats 10 times that same statement. Print t comma x means into in double quote num is equal to comma a t into num, so that statement which executes 10 times because when that condition satisfies that executes the statement by the loop. Okay, here you observe that it represents an infinite iterator. Infinite iterator means infinite, it never stops. Okay, that executes continuously regardless of the condition, means that executes 10 times or 1000 times or 10,000 times, so that prints continuously without stopping that. So such type of loop is an infinite iterator which prints what is that infinite time means which never stops for the execution. Here in this you see that statement, so then iterate infinite iterator. It is not necessary that the items in an object has to be exhaust. There can be infinite iterators, means that condition never terminates. Such type of execution is an infinite iterator. Okay, so it is a completion of iterations or looping. Looping is which repeat the same statement or a set of statement or a block of statements again and again until some condition satisfies. So that's the when the condition reaches that maximum, it will comes out of the loop. So it is an iteration or a looping. Next concept in this Python programming, in this session number 13, another concept is recursion. You are already studied in the first years itself in the C language that recursion. Recursion means which calls the same function again and again by itself is nothing but a recursion. Compared to the ordinary programming techniques, that recursion programming technique is very fast, means it is an advanced concept compared to other programming. Other programs without using recursion, it will take more time for execution. By using a recursion that calls itself by self again and again until some condition satisfies. Here that control avoids moving from main function to the calling function to the main function up to condition satisfies. So that time it repeats there in the subprogram itself. Because of that we are normally using the recursion concept. Here in mathematics and computer science, recursion is a method of defining functions in which the function being defined is applied within its own definition. For example, if you want to find the factorial of a given integer number, so that time we have to write the equation or relation like this: n factorial is equal to n into n minus 1 factorial. So it is also used for generally to describe a process of repeating objects in a self-similar way. Okay. So you observe here in this recursion, a procedure can call itself perhaps indirectly in the general structure of a recursion. So here, if stopping condition, then solve the base problem. Hence use the recursion to solve smaller problems. Combine solution from a smaller problems. Here, each call to the procedure sets up a new execution environment, stack frame or activation record with new parameters and local variables. Okay. When the procedure completes, means that repetition completes, control returns to the calling procedure, which may be in earlier invocation of itself. Okay, so here in this when the procedure completes, means repetition completes, that control returns to the calling procedure, which may be an earlier invocation of itself. Means whenever that calling function reaches the condition, so that condition is false, so that time it returns back to the calling function. Okay, all recursive definitions have to a non-recursive part. You observe the sentence, all recursive definitions have to have a non-recursive part. Means if they did not, there would be no way to terminate the recursive path. Okay, such definition would cause infinite recursion. Infinite means which never terminates. Okay, this problem is similar to an infinite loop, but the non-terminating loop is part of the definition itself. The non-recursive part is often called the base case. You observe here, base case is so simple that they can be solved directly. Recursive case make use of a recursion to solve smaller subproblems and combine into a solution to the larger problem. Okay, larger problem. To verify that recursive definition works, check if base case are handled correctly. Assume recursive call work on smaller problems. Then check that result from the recursive calls are combined to solve the whole. Means normally this technique is applicable for only the small programs. Right, in that small programs we return that code that contains only 2 to 3 lines. One is the what is that base case means condition part, another is the recursive part. In that recursive part, that function calls itself again and again. So that is assume recursive calls work on smaller problems. Normally this technique is used for smaller programs. Okay, you observe here n factorial for any positive integer n is defined to be the product of all integers between 1 and n inclusive. Okay, this definition can be expressed recursively in a recursion equation as 1 factorial is equal to 1. That is the base. Whenever it reaches 0, that 0 factorial is also equal to 1. 1 factorial is also equal to 1. That standard formula is written to normally in the C programming we have to write the factorial equation. Factorial is equal to factorial into I. Okay, that equation should be converted into in the recursion form so that time n factorial is equal to n into n minus 1 factorial. This is of recursive case. A factorial is defined in the terms of another factorial. Eventually, the base case of 1 factorial is reached, so that time which terminates. Okay. Similar to that, another program, it is a standard program in C language also to print the Fibonacci series. Fibonacci series means depends on the numbers you want. Suppose if you take 10, so that prints 10 Fibonacci numbers. Here Fibonacci is the normally that contains first two numbers, either a 0 1 or 1 1, right? That generates the next number is 2, means it is the addition of previous two numbers. The standard equation for printing the Fibonacci numbers, a fib of n is equal to fib of n minus 1 plus fib of n minus 2. Okay, this is the standard equation or a recursive form which prints the Fibonacci series. A last number is the addition of previous two numbers. You can take any number. First you left that first two numbers. After that you observe that 2 is the next series. How it comes means that is the sum of the previous two numbers. You take 3, it is the sum of the another previous two numbers, 2 plus 1, 5, 3 plus 2, 8, 5 plus 3, 13, 8 plus 5, 21, 13 plus 21. Like that, a last number is the sum of the previous two numbers. That is the concept of Fibonacci series, which works recursively, means which calls the same function fib of n minus 1, fib of n minus 2, repeatedly calls again and again by itself until that condition reaches to the final value. So it is a of technique recursion. The large problem is combination of two smaller problems. Okay. Here you observe that recursion definition means we call the function factorial n. That condition, if n is equal to 1, return 1, else result is equal to n into factorial of n minus 1. Result is equal to n into factorial of n. 1 is the recursive form of a recursion, means that statement is written in the form of a recursive techniques. Recursive techniques means which calls the same function again and again by itself. So you take that for loop to generate or print the factorial for I in range 1 to 10, that finds the factorial up to 9, print factorial I. So that should be written in a recursive form that finds the factorial of initial value 1, then final value 10. So that prints the in between range, what the values comes, that prints the factorial of that numbers. Once again you observe that another definition function called Fibonacci n, it's an argument. We have to pass the n number of Fibonacci values. Okay, if n less than or is equal to 2, return 1 in the case of Fibonacci series. Okay, return Fibonacci of n minus 1 plus Fibonacci of n minus 2. It is the form of recursive form. So then for I in range 1 comma 10, print Fibonacci I, that prints the 10 Fibonacci numbers. Here another concept used under these recursions is generating permutations. Permutation, here numerous application requires systematically generating the permutation orderings. Okay, take some sequence of items, example string of characters, and generate every possible arrangement without duplicate. You observe I take a string as 1, 2, 3. A possible permutations or orderings are 1, 2, 3. Okay, it is given 1, 3, 2. Yes, it is another permutation of 1, 2, 3. 2, 1, 3, 2, 3, 1, 3, 1, 2. 3 to 1 are the different permutations of the given string 1, 2, 3. Okay. Here that generating permutation, here you see that example recursion permutation generation for each letter in the word. Remove that letter, get the permutation of the remaining letters, add the letter back to the front. Example, we take 1, 2, 3. You observe that 1 plus first permutation of 2, 3. Okay, 1 plus 2, 3. Okay, 1 plus 2, second permutation of 2, 3. So then 1 plus 3, 2. Interchange, then 1, 3, 2. So you observe that example. So you have to generate the permutations also by using a recursion concept. Okay. Now we come to the end of this session, session number 13. Here that session number 13 is an iterations and recursions. Means recursive is also a type of looping because which repeats itself, which calls same function again and again. Because of that it is also a type of looping. Okay, under that looping that contains iterations and recursions. You don't confuse that two words, iteration and recursion. Iteration, it is very clear to repeat the same statement or a set of statements or a block of statements again and again until some condition satisfies. It is nothing but a iterations. Okay, example for that iteration is using a for loop. Okay. Another part of that looping is a recursion. This recursion is also works like a looping. Means recursion is nothing but to call the same function again and again until some condition satisfies. That technique is called a recursion. Guys, I think you are clearly understood the concept of iterations and recursions. So now today we have completed a session 13. Inside the 13th the topic is iteration and recursions. Okay guys, thank you one and all.